Oh, hi. Mr. Lee here. We're going to be practicing symmetry. So the two main symmetries we've talked about are reflectional symmetry and rotational symmetry. Okay, so if you have reflectional symmetry, that means there's a line of symmetry, right? That's like your mirror position, and it'll take the form of a line. So any line, if it's graphed, you can have an equation for it. And then for your rotational symmetry, you should have a point of rotation, right? It's where your whole graph or your whole figure is rotating around. Okay, so we'll see both examples. First one here, reflectional symmetry, right? It's asking for the reflection line. So we have a black image and a red image. We should be able to identify that the line of symmetry is right here. Okay, should be a vertical line, and it goes through the x value of -3. Okay, so if you need a refresher on equations of lines, I would just open up a Desmos graphing calculator window, right, and just type in some of these equations just to refresh your memory. But if you have a vertical line, it's going to be x equals something. Okay, and it goes through the x values of -3, so our reflection line is x equals -3. Okay, this one's just asking what type of transformation. We're still focusing on is it a reflection or a rotation, right, for that symmetry aspect. This one should be a rotation, right? If we rotate it 180 degrees around the origin, it'll map onto this figure, right? Starting from either one. You can go from black to blue, blue to black. So this will be a type of rotation. There are ways to use reflections to get from one position to the next, but that would require multiple transformations, not a single one. So normally when we're talking about symmetry, right, it's just one single move or one single transformation. Okay, so this one's a rotation. This one's asking for the reflection line. So hopefully you can visualize this. It should be the x-axis. Another way to kind of figure that out is it the same distance from the reflection line between each of these figures, right? So for example, point A goes to this new point A. It's going to be 1, 2, 3 units away from the x-axis, and then another 1, 2, 3 units away. So you know it's the same distance. Okay, so this one's going to be x-axis. Before I move on, it's good to talk about these other equations, right? So x-axis, y-axis, those are your basics. Here's your x-axis, here's your y-axis. The line y equals x would be a reflection across this line, right? If you remember your inverses. If not, you just have to know it's this line. And then y equals -x will be this diagonal line right here. Okay, so if you see a symmetry over one of those diagonals, it's going to be one of these two. Okay, but this one was the x-axis, so let's move on. Do a couple more here. Okay, so here's a good example, right? Reflection line. Hopefully you can see these two figures are sharing this line segment. So automatically that should actually be our line of reflection, right? Because you can flip it around, flip it over this line, and that line segment's going to kind of stay on that line of reflection. So this was our line y equals -x. Okay, y equals -x. Okay, perfect. We're seeing one where we have y equals x. So you could visualize your line of reflection going like here, right? This diagonal line is your y equals x, so we'll go ahead and click it. Let's see if we can find one with a rotational point. Usually your rotation points are going to be 0, 0, okay? But it just depends on the complexity of your function. Reflection line, it looks like we have another x-axis. Okay, I'll do a couple more here. Hopefully the rotation point pops up. If not, then we'll just end the video. Actually, let me just try to find one. Okay, I got lucky on that. But I'm trying to kind of skip some of these. We can do this. Symmetry type. Okay, we have a parabola, right? So the only line of reflection that's possible would be this y-axis, right? If you flipped this whole function over this y-axis, you would then get the same result. So that's what it means by reflectional symmetry.